I better not say anything then. Well, this topic, I think, is one that every health-conscious person should be interested in. It's perhaps the most talked about area in foods, and that is fats and oils. And there really is a bit to talk about, so why don't we get going? Shall we ask for God to guide us?
Yes, sir.
Father in heaven, we want more than just our wisdom or the world's wisdom. And each of us, I certainly need your guidance, your blessing, Lord, to make clear and to learn more. So bless each one of us as we talk over these things. May we see your plan, your way of providing the nutrition that we need, and then go ahead and use it. In Jesus' name, amen. When I was growing up, back in the Middle Ages, wasn't quite 100 years ago, what you heard all the time was how vegetable oil was good, oils were good in general, and fats, you would think of animal fats, they were solid and they were bad. And there is some truth to that, but there's some fine points, some adjustments that we need to make in that generalization. And so we want to do that. Oils, of course, is a term that's usually used for something that's liquid at room temperature. And most vegetable oils are like that, but not all. Coconut fat can be solid at room temperature, and even, I remember peanut oil actually can get solid if you have it in the fridge. I don't know if any of you have seen that. It becomes sort of a jelly-like thing. And then fats, we think of them as being more usually animal-type grease, but there is some animal fat. Fish oils are oils. They're not jelly grease, solid things. Now, the fancy name for these kind of fats that are in food, and they're in almost all foods, although in some of them they're in very small quantities. You know, even spinach has some fat. And the fat that it has is very high quality, but it's very little. All of these things that are called fats and oils, the fancy word that is used is triglycerides. And we'll show on the screen. Maybe I can jump to that right now if I can learn how to run this. Yeah, this. I don't have a nice picture of this. There we are. But it's not the whole. These are parts of the fat. Triglyceride, the reason it's called triglyceride is it's got three chains that come off of a backbone. Each of the chains connects to the backbone, which is a molecule called glycerol. It's sort of like half of a sugar molecule. So you've got three chains. It can be rather long, 16. We're going to talk a little bit of chemistry here so that you can become, you know what you're talking about. If we use terms like saturated fat, unsaturated fat, it's nice to know what that means. And it'd even be nice to know, what does omega-3 mean, and omega-6? These terms are used in the nutrition industry now quite a bit. In fact, go into a health food store and you'll see lots of those terms. Well, it's good for us to be up on what basically is meant by that. So to know, you really need to get a little bit, not into a huge amount of detail, but you need to get into a little bit of detail in the chemistry. And so fats and oils, the reason we put them together is they are a similar structure. The triglycerides then, like we said, have three branches coming off this one chain. And these branches are basically carbon atoms with hydrogen around them. Now, what's water made of? Hydrogen and oxygen, H2O. In fats, you have lots of hydrogens. You can see them all up here. all these H's, and you have lots of C's. And carbon has 4 arms by which it links. Well, we could think of 2 legs, 2 arms. It's got 4 linking positions that it'll attach by. And if you were to look closely, that's true of every case here. Each C has 4 arms going off it. Hydrogen has only 1. It's got 2 legs amputated and 1 arm amputated. So it's got 1 thing to link by. And these are part of the fat structure. It's a whole lot of carbons and hydrogens and very little oxygen. You can see just 2 oxygens over at the far end there. Now, when fat is digested, the 3 arms that are attached to the backbone are separated. And each of these arms goes off on its own and becomes a fatty acid, it's called. So when you hear about fatty acids, yes, they're part of fat. That's why they're called fatty. But they're not the whole fat. They're just one of the arms on its own. So you see here just one of these arms like this, but it's not attached to the backbone. If the backbone were there, you'd have 3 like this. Now, the term saturated fatty acid means that it's a structure basically like this. It's got all the carbons linked to each other by 1 bond. Unsaturated fatty acids, or unsaturated oils, if they're part of that group of 3 fatty acids on a backbone, unsaturated ones, instead of having all single links between the carbons, they have some double links. In other words, the carbon, one carbon can be attached to the other one by a single arm going out, or it can have both arms going out, and the other carbon has its 2 arms going out, and it's linked in a double way like that. Now, the reason it's called unsaturated is that you can put one of these unsaturated fatty acids, or oils that are unsaturated with those double bonds, you can put them in a setting where you have the right temperature and some right helping materials, catalysts. You bubble hydrogen through it, and you lose the double bond. When you put more hydrogens here, this double bond becomes a single bond. You could work it out for exactly how much. Turns out you have to, for every single bond, every double bond, you have 2 more hydrogens that would go in place. Well, it turns out that the saturated fatty acids usually are more solid than the unsaturated ones. I should say the oils that have unsaturated fats. The unsaturated oils tend to be liquid, and that's more usually vegetable oils. When you have it all single bonds, saturated fatty acids, saturated fats, that more likely will be a solid. And like we said, that usually is the case in animal fats, but not exclusively. In fact, the most saturated fat that is known is coconut fat. It has almost exclusively those single bonds, none of these special double bonds. Now, here's another word for fatty things. Now, we've already given you one, triglycerides. Triglycerides is the name of your average fat, oil or fat. But the subject is actually a bit bigger. There's other things that are kind of like fats and oils. They have that similar property, like, for instance, they don't mix with water. We all know that. Oil doesn't mix with water. It'll separate right away. So there are other things than just the usual fats. And so a more general term that's used is lipids, L-I-P-I-D-S. And the term lipid includes one of the substances that you've all heard about a whole lot, cholesterol. But it includes some others as well that are in our bodies. You don't hear quite as much about phospholipids and some other things that are in the brain and in the nervous system. Now, I wonder if I can find here a picture of, I just didn't have enough time to get all this together really like I would have liked to, taking care of patients too. Let's see here. Somewhere I think there's a picture of cholesterol. No, I don't see it. Well, did I have one there? You saw it? No. Oh, there we are. Thank you. Was it Mark? Thanks. This doesn't really show you much of what's actually in it, but the structure is there. Every angle is a place where there's a carbon atom. So this structure with a bunch of hexagons in it and then a little tail up at on the top to the side, this is cholesterol. So if you were to count up the carbons, I don't know, it would be something like 18, 20. There's actually carbons on that tail as well. Every time you have a bend, it stands for a carbon atom, and then there are hydrogens along the way. So this cholesterol, you look at it and compare it with the triglycerides, which are symbolized here. You see it's very different looking. The structure is very different, but actually the components are rather similar. It's basically carbon and hydrogen with very few oxygen. So this triglyceride, we said that if you break off the glyceride, if it becomes free, it's called a fatty acid. The term glyceride is used more for when it is attached. And the backbone here, if you want to remember the term, it is glycerol or glycerin. Okay, now we think of cholesterol as being a problem. And yet your own liver, all of our livers, make cholesterol. In fact, it's the building block for a number of hormones in the body. Well, that being so, then why all the fuss about cholesterol? And triglycerides can be liquid or can be solid, even if they're plant. Then why all the talk about certain ones being bad and other ones being good? That's what we want to address. It is true, we actually need cholesterol. And our livers make all that we need. You don't need extra cholesterol to come from your food. In fact, the problem that happens with cholesterol in food is not because of the cholesterol structure per se. It looks, from research that's been done for a number of years now, that the problem is that the cholesterol that a person eats has gotten oxidized. It's been exposed to the air. When that happens, it changes it so that it becomes toxic, you could say. It becomes sticky. It starts sticking to the walls of the blood vessels, and that's what we don't want. So that means that if we're going to avoid all of that problem, what foods do we need to avoid? It really does mean you have to avoid animal products, because pretty near all animal products have cholesterol. Any form of meat does. A lot of people think of eating fish as being really good for you because like we said, the fat in fish is actually oily. It's not solid. So they say, well, you know, it's like vegetable oil. And they think of fish as not having cholesterol. You know, pork and beef have cholesterol. Well, the truth is, even though fish has less cholesterol than the land animals, in fact, it does have cholesterol. If a person goes from a high meat diet, by meat I'm saying, you know, beef and pork, If he goes from that, replaces all the meat that he was eating by fish, it is true his cholesterol level will drop. But if he goes further and eliminates all the fish, his cholesterol will drop further. And a person that is a total vegetarian, a vegan, who adds fish will have a rise in his cholesterol level. Yes?
Can your cholesterol become too low?
Well, that's a good question. Some people talk as though it can get too low. Maybe partly out of the problem that one sees, say, in an advanced case of cancer. Cholesterol will drop and keep dropping. The problem isn't the cholesterol, though. It's the cancer. When they did studies about that very issue in China, what I have heard about that is that they saw cholesterol levels that were way down at levels that are considered too low here. And they didn't see any increased problems. People did. In fact, the rate of all the problems that occur with cholesterol kept going down with low levels. Occasionally, pretty rare here, but occasionally you'll see a person with a cholesterol total less than 100.
I have a question about people that do eat hamburger or any types of meats. What if it's boiled, and you can use a screen, to screen out the fat. I wonder how much fat would still be left.
Well, maybe you could get rid of quite a bit of it.
Because when you boil it, there's no more blood, no more fat.
You're sure that all the blood leaves? Because the blood coagulates. It is true, I think you could boil off or separate off the fat because it floats in the water. At the school that I did an academy in, they said that they in previous years had served meat that they had really drained the blood from very well. And I don't know if they did what you said, but the students, some of them were meat eaters, they said when they ate it, it tasted pretty bad. The taste of the meat, quite a bit of it comes from at least a little bit of blood and urea being in the meat. So I don't think that was enticing to them. Now, in the cholesterol that's in our blood, it's not just that way. It's always bound with some other molecules, other structures. The term that's used is lipoproteins. Lipo, or lipid, means a fatty part. And then there's a protein part. Now it's an interesting combination because the fatty part, the lipid part, does not want to join with the water. Just like oil, it wants to separate from the water. The protein part gets along fine with water. It dissolves in water. Now, the cholesterol is bound up in these molecules that have varying amounts of protein. Some of them have just a little bit of protein, and in that case, the lipid, the cholesterol part, dominates. And which is lighter, fat or water? The fat is. If you notice, every time that you have water and oil, it's always the oil goes to the top. Oil is lighter. And so if you have a molecule in which the proportion of fat or cholesterol is quite a bit higher than the small amount of protein, protein fits in the water, then the lipid part, the fatty part, is going to be lighter, and they call that a light or a low density protein. It's a low density lipoprotein, for short LDL. Now, if the protein part of this combination is big, then instead of a low density lipoprotein, it's going to be a high density lipoprotein because most of it fits with the water, which is heavier than the lipid part. Now, I want to show you a picture of, by the way, this that we were just looking here, oh, it doesn't have it up there. There we are. These little balls are balls of the cholesterol. Now, it hasn't illustrated the cholesterol tied in with the protein. But you can see that these little balls of cholesterol, well, I guess you can't see that it's happening, but it is. That's the very thing that is making up this plaque, this deposit of cholesterol that is narrowing the channel of the artery, so that it means that the blood flow is not going to be as good there. By the way, this gives you the sources of cholesterol. That's what the whole slide is to show you. And it shows what I was just saying earlier. For cholesterol, you can get it from almost any form of animal food: eggs, cheese, meat. Milk has it. By the way, skim milk, people think of skim milk as having no fat. Skim milk actually does have some cholesterol. It's not a very high amount, but it's very definitely cholesterol that's in it. And then, down on this side, your liver makes cholesterol. Now, it turns out that the low-density lipoprotein, by the way, which part of the molecule dominates in the low-density lipoprotein? The one that has the cholesterol part comparatively more than the protein part. That one has more urge to get out of the water of the blood than the one that has a whole lot of protein. The protein likes to be in the water of the blood, stays dissolved there. But the one that has proportionately less protein is much more like an oil and quite ready to separate, and it's going to be the one that makes that plaque. So the low-density lipoprotein, the LDL, is what's called the bad cholesterol. Now, I don't know if there is some good use. I'm sure there might be some good use, but it's definitely often the cause of people's problems in plugging arteries. The HDL is the one that has the big protein. Now think of this for a minute. It does have cholesterol there, and that part of the molecule likes fat. And so in an HDL, the cholesterol part kind of likes it when it's there by the plaque. It kind of fits in there, and it kind of sticks a little bit with the greasy or waxy cholesterol deposit. But the big protein tail that wants to be in the water overcomes it, and it pulls away, and it will often take with it some of the cholesterol that had been deposited before. So the HDL does just what you want. It doesn't build the plaque, it actually takes it away. It's diminishing the plaque. So you want your HDL to be high. Now, in your blood work, it'll tell you your total cholesterol, which includes both the HDL and the LDL. And a very important feature of that is what is the proportion of the total cholesterol that is the good, the HDL. In fact, it's dealt with as a separate unit in many lab reports. They'll say, here is the ratio of the total cholesterol to the HDL. You'd like the HDL to be high, and you'd like your total cholesterol to not be so high. So the ratio of the total to the HDL you'd like to be low. Or you could put it the other way around if you wanted. You could say, we want the fraction of cholesterol that is HDL up here, divided by the total. We'd like that to be as big a fraction as possible. But the way they usually give it in the labs, and any of you that are having your lab work done, they do it the other way around. They take the total and divide it by the HDL, and then you want that to be a low number. You I don't know if this is going to be dealt with later in the week. You'd like to see that. We like to see that less than 4, that number. The ratio of the total cholesterol to the HDL. Okay, let's take a look at further back here to see if there's anything here that we can talk about. So this was we were wanting to take a look then at what's wrong with animal fat. Well, the problem is that cholesterol that's often in the animal sources of fat. There's a definition of lipids that we've already talked about. This you see up there where it says triacylglycerides. This is just a fancier word for triglyceride. Fats, oils, and butters. And the 3-chain combination that makes up your triglycerides during digestion, right in your stomach and just following the stomach, those are all broken up. And what goes into your bloodstream is not the triglyceride, it's the fatty acids and then that backbone, the glycerol. And once it gets into your bloodstream or into your lymph system, which is sort of like a bloodstream of its own, they get together again. And so you actually do have triglycerides in your blood. And that's what will be on lab work as well if you get it done. They'll tell you this is your triglyceride quantity, and then it'll go into your cholesterol, your types of cholesterol. Okay, we've covered some of those things already. Here is how absorption takes place. I don't think we'll get into the details there. Now here is a big issue. It has to do with what are called trans fats. Y'all heard about those? Okay. It's quite a topic for anyone that is at all interested in health. Nowadays you see this around all the time. In fact, in some jurisdictions, and I think even the federal guidelines are trying to get people away from trans fats because of their danger. Now, what is the difference between a natural fat, a natural triglyceride, and one that has trans in it? Well, here, this is the natural form of the chain. The term that's actually used for that is cis, C-I-S. And in a molecule of natural fat or oil, at the double bond, each of the carbons has only one hydrogen atom. And then on the other side of the double bond, it has the chain continuing. That's true on both sides. In this natural one, the side that has the hydrogens is the same side, so to speak. And the arms that have the continuing chain is on the opposite side. That's the natural way that the double bonds are. In vegetable oil, actually in animal fats too. They're all that way, that the chain, if it's on this lower side or upper side, it's the same on both sides of the double bond. When you go to an oil that has been changed by processing, if it's been affected, damaged, you can get this flipping. Do you notice this side over here, you've flipped this, and so now your hydrogen is opposite the hydrogen that came up to the double bond. So that looking from one hydrogen to the other one, you're looking across. It's transecting, it's transversing across the double bond instead of being on the same side. And the same is true of the continuing chain. This trans type of molecule can be produced purposely when they hydrogenate foods. Now, when you hydrogenate, if you do it completely, you change the double bond so that the one of the bonds that are double gets replaced by hydrogens. Then you just have single bonds. That's a saturated fat. There's no trans or cis to it. But what happens when you overheat an oil, or if you do partial hydrogenation, is that this double bond in its natural state can shift from a cis to a trans. And these trans bonds, the first thing about them, it makes them act a bit more like a saturated fat. That's one thing. Another thing about them, actually, the thing that's useful, why the industry does this quite a lot, is that since it's not in nature, it doesn't degrade. Even bacteria don't see it as something that's edible. And so it doesn't go bad. The shelf life of oils is really long when it's got trans fats in it. Well, if the bacteria find it inedible, maybe we should too. There's a lot of discussion and research that's been done and is still being done on the problems with these trans fats. They are worse for plugging the arteries than the ones that are not trans. There's even suspicion of unrelated diseases. I heard of there even being a concern about them being related to development of cancer and so on. Now, how do we avoid then getting these trans fats?
Every package now tells right on there how much trans fat.
Yeah, a lot of...
The back of it?
You know, they can get around that problem. That's if they tell you that there's no trans fats, then that's good. But often they don't tell you. And the food manufacturers know that people have heard about how animal fats are a problem. And so, they won't say this has lard in it and, or other animal fats. What they will say instead is that you've got a diglyceride or a monoglyceride, and I'd have to show you what we mean by that. Let me just go back here. You see the bottom right there, the triglyceride? If you cut off, as happens in digestion, if you cut off one of these glycerides, one of these fatty acids, what's left is not a triglyceride, but a diglyceride. If you cut off two of them, then what's left is a monoglyceride. And if you look at food ingredients, quite often you'll see that this food has diglycerides, monoglycerides, which tells you nothing about whether they're trans fats, doesn't let you know the origin of the fats. Now, they may say that it's vegetable diglycerides or monoglycerides. Then you know that it's from a plant source, but you still don't know whether you've got trans fatty acids, trans fats in it. If they label it specifically as having no trans fats, that should be safe. Want to go back up here. Okay, this is an explanation of what we went through a little earlier. The low-density lipoproteins deliver cholesterol to the body, and that's the kind that sticks on the wall of the arteries. The high-density lipoproteins are the ones that remove the cholesterol from the bloodstream. It's the good cholesterol. Here you're seeing blockage in a coronary artery. And they're showing you that it's taken from this very spot here. This would be a diagram of someone perhaps that had a fairly large blockage, and what they do is go in and actually bypass that area with veins or arteries from elsewhere in the body. It's a huge procedure. You know, I don't know nowadays. I know that 20 years ago it was $50,000, $60,000, and now I'm sure it's quite a bit more, where you would have another artery or vein go down here below and then attach it up above the blockage here that's shown on the right.
All these blood thinners they give you, that doesn't really help the problem then. I mean, like to eliminate it.
Yeah.
Extends the blood.
You could say that there are really three problems occurring. There's first of all the mechanical blockage, which you saw in that artery. You've got it, obviously the blood isn't going to be able to flow as well because you've got the cholesterol junk there. So that's a mechanical problem. Secondly, there's an inflammatory problem. The cholesterol that's laid down like that causes an inflammatory reaction so that white blood cells will try to engulf and eat up the cholesterol, and it'll go into the wall of the artery, which is a little better than having it exposed right outside, but that inflammation isn't really so good. We see higher levels of that inflammation in people that are at higher risk for, a heart attack. A third process that's happening, when you get the inflammation and the blockage high enough, what happens as a final step before complete blockage is clotting sets in. And the clotting mechanism is a complicated cascade of many different things that enter in. So that happens over a period of hours to even minutes. Once you get that clotting occurring, it's quick. Now the buildup of cholesterol takes years, the mechanical part. The inflammation perhaps a bit less, but it's kind of long term. But that clotting is quick. And to try and stop the clotting, the final stage, is why they recommend people take aspirin. But aspirin doesn't really deal well with all the whole underlying problem, just with that last step. Now it is true that happens quickly, and if you inhibit it by taking aspirin, it will allow you to last longer. The trouble with aspirin is it actually poisons the clotting mechanism so it doesn't work well, and so the person then can bleed easier. A much better way to do it is, in addition to the diet changes to avoid all the cholesterol, is take garlic. And there are other natural anticoagulants that can really help with avoiding the clotting. So you can take care of those two aspects as well as anti-inflammatory simple means. White willow bark is anti-inflammatory. Flax seeds are anti-inflammatory. Now, I want to take a look here. This was apparently in the year 2000. Oh, there we are. The U.S. consumption of foods by, different categories. What it's calculating is the percentage of calories in different categories. So grain products are way up there. It's not a surprise. People eat lots of bread and spaghetti and things that have grains, lots of buns and cakes. Fats and oils are way up there too. We're over 20% here, maybe 4%, and fats and oils are over 20% of the calories that people eat in the U.S. Sugars and sweeteners are a little further behind. And then next on the list, meat, poultry, and fish, eating the animals' bodies. And then dairy is the next one down. Look where the wholesome plant foods are. The greens, vegetables, fruits, legumes, nuts, and soy. They are way down. Now, people aren't eating so many of the eggs. You see the eggs over there. There's a small amount there. But they sure are still eating lots of these things that contribute to the problems that we've been talking about here. Only 10%, 10.6% of calories come from vegan food. Now, strictly speaking, grain products are vegan. But if you're wanting to have a diet that's going to trim down the average American, you know, the average American is pretty hefty, pretty hefty in size. Grain foods are a very concentrated way to get calories compared to other forms of plant food. So it's better to go easy on the grains if there's any weight problem. But from there on, you're dealing with concentrated and foods and unwholesome foods down to dairy products. So if you count the greens as the best foods, only 10.6% of the calories come from those greens, legumes, and fruits.
What about like steel-cut oats? If it's cooked real good, that doesn't have anything to do like digestive.
Oats are probably the best grain of all the common grains that we eat because the fiber, a lot of it in oats, is soluble. It's easily handled by the body, and it's really good. It is better for blood sugar. Oats are better than wheat and other grains for blood sugar. Now, here what I've put up is, or what my wife gathered these. This is a list of different kinds of fatty acids. Now, I want to make clear this point about the triglycerides, the oils. We've already said several times how there are 3 branches on this backbone. And the difference between different kinds of oil or fat rests exclusively on what kind of chain do they have. The basic structure is the same. They all have the 3 chains. And the backbone of the chain is the same whether it's an animal or a vegetable type oil. What makes the difference is what does the chain have in it? How many double bonds does it have? It's very important. So among the fatty acids that have several double bonds, there are 2 that are considered essential. That is, we need them. We can't get along without them. And the name of one of them is linoleic acid. This is kind of small for you to see, maybe. Linoleic acid up on the left, upper region, is in quite a few vegetable oils. It's called an omega-6 fatty acid. We'll see if we can get to explaining that. The other essential fatty acid is called linolenic, or if you want to make it more complete, alpha-linolenic, Linolenic. And this one is an omega-3 fatty acid. And then it has several brothers and sisters down here. The linoleic acid has several others that are related to it that are omega-6. And what it's saying over here by the line of omega-3 fatty acids is that there's a number of foods in the plant realm that have these omega-3. Green leafy vegetables, flax and chia seeds, canola oil has a fair amount, walnuts, and soybeans. Now, here are 3 fatty acids that are of the omega-3 type that we hear so much about as being way better than the other fatty acids. The reason they're considered better is that most people don't get enough of them. You do need omega-6, and then some people just don't get enough omega-3. So that can make an important difference for health. These 3 omega-3 type fatty acids are found, we already had mentioned the foods that they're in. The ones that are below here, not the linolenic acid, this one, it's a bit of a mouthful. I think it's eicosapentaenoic acid. And this one, docosahexaenoic acid. These 2 are in fish oils. And knowing that omega-3 oils are needed, that they have good properties in the sense of they're anti-inflammatory. In fact, they've even shown that omega-3 fatty acids in the blood are higher in people that are not depressed, and people that are depressed have low omega-3. So there's lots of push for getting omega-3 fatty acids into people's diets. And so that's often interpreted to mean you better eat fish. There's something else about the omega-3s, these 2 particularly, is that they have many double bonds. This eicosapentaenoic acid has 5 double bonds. That's quite a lot. The next one has 6 double bonds. And when you have that many double bonds, it is anticoagulant. It becomes rather strongly anticoagulant. And in fact, in people whose diet is highly fish, they can over-anticoagulate to the point where they have bleeds occurring. In people that lived in the old-style Eskimo way of eating, mainly fish and other sea creatures, one of the main causes of death was bleeding into the brain. The first one there, alpha-linolenic acid, has 3 double bonds. It's not as anticoagulant in action, but it gives you the omega-3 that you need, and to the extent that the body needs others, it can make it. It can make these second and third omega-3 type fatty acids. Where do you get that omega-3 acid that is linolenic, alpha-linolenic acid? Flaxseed is the biggest source. In fact, flaxseed outdoes the fish oils in omega-3. It's about 50-60% omega-3, whereas the fish oils are about 30%. So you're not lacking in omega-3 oils if you get your flaxseed. You have a question? Yeah.
But is it true that the fish oil or the flaxseed oil has to go through another process that fish oil doesn't?
Especially in the nervous system, some of these other ones with more double bonds are needed, and our own body does the transformation. You don't want a whole load of those double bond oils with 5 and 6 double bonds. To the extent that you need it, it can do it. So there you are. There's those little flax seeds. And there they're telling you it's happy for the heart. The cup, it must have flaxseed oil in it. Now, some people, in light of these things, actually use flax oil for cooking. I wouldn't advise that because flaxseed oil, in fact, any oil that has several double bonds, by several I mean 3 or more, it becomes rather unstable. Even just being in the sunlight can change it, being exposed to air. If you're going to get flaxseed oil, get a dark container and keep it in a fridge. A better way to get your flaxseed oil is to get it in the flax seeds. And blend the flaxseed, and it grinds it to, just a regular blender. We'll get it down to a powder, a meal that is sufficiently fine. And about 30% of the weight of flax seeds is oil. You don't have to be taking it in the form of a liquid. You can just take that flax seed, sprinkle it on your foods. To my taste, it goes well with either vegetables or with fruits. And you get a tablespoon or two a day, and you're getting a wonderful medicinal dose of God's medicine. Yes?
What's your opinion about coconut oil?
Okay, that is a very interesting question. Since we said earlier, the coconuts have an oil that is very saturated. It's even more saturated than animal fats. So let's see if I can, we have a write-up on this. Here's a rather long descriptions of trans fatty acids and hydrogenation. Let's go here. We can come back to some of these. Oh, here we are. Just a minute. Here we are, coconut oil. Coronary heart disease is basically what we just presented, you know, the plugging of the arteries that feed the heart. By the way, you know, the blood that the heart pumps doesn't actually take care of the needs of the muscle that the heart is working like that. Instead, you have to have blood vessels, arteries coming off the big aorta that comes out of the heart. It comes back on the outside of the heart and then feeds branches right into the muscle of the heart. So the blood that goes through the chambers doesn't do any good to the heart muscle until it comes back from the outside and penetrates into the wall. Those arteries that do that are called coronary arteries. And those are the ones, when they get plugged, that's what causes a heart attack. So, heart attacks are now happening all over the world at increasing rates in countries that have been poor traditionally, and they've looked to the American way of life and thought everything in U.S. is paradise. And so they want the McDonald's hamburgers and everything else. And so they're now getting their toll of heart disease, just like U.S. has had. Coronary heart disease is common in India, and recently an increase in the incidence of coronary heart disease was reported from the South Indian state of Kerala. Now, here they're pointing out that the traditional Indian diet was low in fat content. Traditionally, Indians, and this could be said of many parts of the world, including the indigenous people of America, all through South and North America, their diets had very little fat. They would eat some meat, but not a high percentage of meat. And certainly it was very true in India because, you know, the whole Hindu thing is not to eat meat. So it was a low-fat diet. The high incidence of coronary artery disease, coronary heart disease in Indians is therefore, in contrast to Western studies that have correlated high fat, saturated fat, and cholesterol intake to coronary heart disease. Now, what they've noted now is consumption of coconut and coconut oil that contains high amounts of saturated fat are thought to be strongly atherogenic. That is, modern researchers in nutrition know that when you have saturated fat, the way saturated fat usually comes in most diets is in a form that does tend to plug arteries. The cholesterol may start the problem, but the saturated fat tends to add to those plaques, to those deposits. And so that's called atherogenic. It makes these blocks, these plaques. So these are thought to be strongly atherogenic, that is, consumption of coconut and coconut oil. And it was believed that that was one of the main reasons for the high incidence of coronary heart disease in Kerala, this part of India. To explore this presumed link, it's a presumed link because it wasn't really proven separately. It's just known from this continent that the people that ate the most saturated fat had more heart attacks. But most people in this continent who eat a lot of saturated fat, what's their saturated fat coming from? From animal products, not so much from coconut. But anyway, they're checking this out. That's what this study is about. To explore this presumed link, we studied 32 coronary heart disease patients and 16 age and sex matched healthy controls, people who didn't have the heart disease. Consumption of coconut and coconut oil was found to be similar in both groups. The amount of coconut each group used was basically the same. The groups did not differ in the fat, saturated fat, and cholesterol consumption. The results imply no specific role for coconut or coconut oil in the causation of coronary heart disease in the present set of Indian patients from Kerala. The exact reason for the high and increasing incidence of coronary heart disease among Indians is still unknown. What is this telling us? It's telling us that the ones that were healthy ate just as much coconut. We should have seen the ones that were healthy to have been eating little coconut if coconut was the cause of the problem in those that had the disease. So they're still mystified by it. I don't think we need to be mystified. In India, like in most parts of the world, even in communist China now, McDonald's hamburgers are getting going. All over the world, there's more general meat consumption in the poor countries. Here, it's gone down in some quarters. And in fact, the rate of heart disease has gone down in a number of states in the U.S. because of awareness of these problems. Here's another point. A population study. It says population studies show that dietary coconut oil does not lead to high serum cholesterol nor to high coronary heart disease mortality, that's death, or morbidity, sickness rates. The cholesterol lowering effect of essential fatty acid rich corn oil may really not be so beneficial inasmuch as the HDL cholesterol is simultaneously decreased. Now this is an interesting point. The people that are getting a whole lot of linoleic acid, the omega-6 type, are really not getting the benefit that flax would give them. The problem is that the HDL, that protective cholesterol, starts going down. And one more study here. This was done in Brazil, Rio de Janeiro. And what they talk about first here is that they call it the universe of people, just all over the place on this planet anyway, with coronary artery disease has been increasing steadily worldwide, and that's very clear. Way more people are getting heart attacks. And associated intimately with certain cardiovascular risk factors, such as dyslipidemia. That means their fats are out of kilter. You know, the fats that we just talked about, the triglycerides in the blood, the cholesterol types they have. Dys means bad. So the rate of incidence and a bad fat picture in their blood is part of this. A high intake of saturated fat in different populations is associated with elevated serum cholesterol concentration and cardiovascular mortality. More people are dying. However, studies have shown that extra virgin coconut oil, despite being characterized by its high content of saturated fat, was not associated with obesity and a bad fat picture in the blood in populations that have had high consumption of coconut. So some of the things that have been said in the past, blaming all forms of saturated fat, actually are not true. It's true of the kind of saturated fat that lots of people eat here, but it's not true of coconut, which is more saturated than any form of meat fat. The basic rule to take home from this is not to avoid all forms of saturated fat. Instead, the rule is simpler. It's a rule that was given back in Genesis 1. The perfect diet for mankind is a plant-based diet. So don't worry too much about all the technical terms. To me, it's very interesting. As you get into all the technical things, it just makes even clearer the original plan that God gave is really the one that we should follow. I don't know if you have any questions. Yes, Michael.
I had a question about if you're going to cook with oil, what is the best oil to cook?
Real good question. If you have vegetable oil, every time that you use a vegetable oil with a double bond in it, the double bond, I think we already mentioned this, the double bond is a bit unstable. Light and oxygen can change it. And you don't want it changing because it can change to trans. And the one thing you want to avoid the most is overheating oils that especially have lots of double bonds. If you are someone that really wants to fry things in oil, what would be the best oil to use? Coconut oil would be the one to use. Now, we don't counsel you to do a whole lot of frying.
How about popcorn? I don't like the air popper.
Yeah. If you're getting the oil heated any, you are way better off with coconut type oil. Now, usually popcorn, you know, by the time it gets out on the table to where people are using it, the temperature is down. It's worthwhile knowing what temperature you get this shift. That shift, when you overheat an oil, it starts shifting to trans. At a temperature in Celsius, it's 160 degrees Celsius, which in Fahrenheit is a little over 320. Now, when you're baking bread that has oil in it, the moisture in the bread tends to keep it down some because any water that's still in the form of water has the boiling point much lower than that. But if you're heating oil itself can get very hot. It can go way up beyond 300 up to 400 degrees. So deep frying is a real problem. Nuts, it's already proven by a number of studies, nuts can do a lot of good for you, but the thing that you shouldn't do is eat those nuts when they've been deep fried. You know, a lot of the nuts that you get in the stores in the little packages have been deep fried in some other oil, and then you've got a whole lot of trans fats. Yes?
What about olive oil? Is that in the oil as well?
Okay, maybe this would be a good point to finish on. Of all the commercial oils that you get in the big department stores, the big supermarkets, I have to say honestly, I believe that all of them should be condemned except for olive oil. The reason I say that the other ones really shouldn't be eaten by a person that's careful about their health is, if you study it out, you find out that they use high temperatures to process those oils. You want cold pressed. You could get other than olive oil if you go to a natural shop, a health food store, and you get a cold pressed oil. You're going to pay for it, of course. But olive oil, even the big commercial forms, if it says extra virgin, in general it is cold pressed. Yes?
What about grapeseed oil?
Yeah, grapeseed oil is supposed to be very good for you. I'm just not sure how close what kind of temperatures they use in producing that. Some of this is a little hard to get information on. I can tell you there's a really excellent book that we've used for years here at Uchee Pines called Fats That Heal and Fats That Kill. And the author of that book said he would go and try to get information from the manufacturers of oils, and he said it was very hard. They didn't want people to be investigating all these things. But he has a lot of information there if you can just throw out his comments that are based on evolution. It's otherwise a very accessible and worthwhile book. Okay, I think we'll finish there and give you a break.